Hello everyone and welcome to another video of Vivek Learns. In the last video of PepCoding Recursion that we had made, we had revised this question, print array in reverse. So we were revising all the questions that we had solved earlier. So we started revision with this print decreasing function and we continued our way to the print array reverse question. So in this video, let's continue revising the questions. And the next question that we are going to revise is this max of an array question. So this question says that we are given an array of elements and we have to find maximum element which is present in this array. So let's analyze it with the regular approach that we have. So let's suppose we have an array ARR which has, let's say, 29 T and 16. Okay. So the expectation is if we have print array max and we have ARR comma the index or the first, what should we give? We can give the length of the array. So we can give 5 is the length, right? No, 4 is the length. Yeah, my bad. So what should it return? It should return the element which is the max, which is 29. This was the expectation, right? And let's set some faith. So what is the faith that we set? The faith that we set is if we have array, so what diff does it? It will start from the last index and it will all the way iterate to the 0th index and find the maximum. So the faith we established is if we have ARR comma 3, then it will start from the last index and it will scan all the elements to one less than the first index, like till the first index, and it will return the maximum. So the maximum till the first index is 20. So this will return 20. So how do we go from fate to expectations, right? So for going from fate to expectation, we'll have to compare the previous max, it's 20, with the next element in the iteration, like the first, the 0th element that we have, right? So what do we do? We get the previous max, int prev max is equals to this, right? And then we compare the previous max and the new element. So what do we do? If ARR of uh, n, so what is n here? N will be 4, right? So that is, let's consider that int print array max of 3. So we'll get all the maximum present in these three. So we'll have to consider this element now. How will we get the first element? So we can get the first if we have if ARR of 0 is greater than mm, prev max, right? Previous maximum, then return ARR of 0. Else we return prev max, right? So this is the format that we can write. So now we have to think how we can write it in an generalized format. So this is nothing but n minus 1. But how do we get 0? So we can get 0 if we have ARR dot length minus 1 minus n, right? So we'll have something like uh, copy all this, have it pasted here, arr comma n minus 1, and here we'll have arr dot length minus 1 minus n. Okay, and if it is greater than pref max, then return this element, right? Else return pref max. So let's consider how the flow will go now. I'm sorry. How will the flow go now? So first, what do we do? So the first, we will call this print arr max with arr comma 4, right? So if we call with arr comma 4, it will come here. It will call again a method with n minus 1, so it will give us the zeroth zeroth no, not the zeroth element, n minus 1, right? 4 minus 1 3, then 2, then 1. So we'll keep on adding the stacks, right? So this will call this, this will call this, this will call this method, and this will again call this method. So we'll have to have some base case. So the base case, let's define it like we have the base case as if n is equals to is less than 0, let's say. If n is less than 0, then we return. And what do we return? Hmm, this is where I have the confusion. Like, do we return? We have to return something, right? From this method, we have to return something. So if n is less than 0, we return arr of 0. Let's, if n is less than 0, then what should we return? We should return an arr of 0, let's say. Or we can consider if n is equals to 0. And if we return from there, solve to arr dot length minus 1. But let's consider this base case that if n is equals to 0, we return arr dot 0. So if we return arr dot 0, we'll fall into this stack. And in this stack, what will happen? Arr dot length, which is 4 minus 1 3. So which element will get? If n is equals to 0, then we should return the last element, right? We are starting the comparison from the last element. Yeah. So we should give return the last element, arr dot length minus 1. Yep, this is what we return. Yeah. So once we return the last element, we return 16. Then we return here. And what happens when we return here? The statements will be executed. So prev max becomes 16, and we get arr. Arr dot length is 4 minus 1 3 minus 1. 3 minus 1 is 2. So 0 1 2. So it will compare this and then the previous max. So 16 will win, right, in both of these comparison. So yeah, this will work. So let's see how we had solved this. Print array max, right? So I think we had solved it in a different way. Yeah, but the basic idea is same. But let's try to execute a solution 3 in the way that we are thinking, right? So I'm just trying to have a wider perspective here and solve the same problem with different solutions. So if we start from I'll start the solution 3 here from arr.length. This is solution 3. And we retrieve the previous index, we do index minus 1, right? And we do arr of arr.length minus 1 minus n. And if index is 0, index right, not n, we return this, right? Otherwise, we return this. Is we return previous max, right? Yeah, let's try this. So if we'll start the iteration with 5 as the array.length, and then we'll hit this line continuously, recursively till we reach 0. Then we return the last element, which is arr of arr.length minus 1. Then we compare that previous max with arr.length minus 1 minus 1, which is arr of 2, and then we'll keep on falling down where index keeps on increasing. Yeah, I think it will work. Let's try to execute it once. So we'll have, let's consider this as the element, right? So we'll have 29, 20, 13, 16, 4 elements. 20, 13, okay, 13 and 16. We got array index out of bounds exception. So what did we do wrong? We are passing array.length only, right? Oh, we are calling it 2 times. We have to call it only using this. We pass it 4, 29, 20. Hmm. We are again hitting array index out of bounds exceptions. So there is something which is wrong. Mhm. What is wrong? Where are we getting it? On line number 58, which is this line. So hit retrieve array of index, comma, index minus 1 recursively, right? Array.length minus 1 minus index. We are getting minus 1 as the index out of bounds. So we are going one step further, and that is not what we want. So if we have array.length compared with previous max, arr.length minus 1, it will give us the last element. Then let's consider the the end case or the edge case. arr.1, arr.length minus 1 will give us 16. arr of arr.length minus 1 when we hit 0, right? Retrieve max from an array. We are reducing the index, and then we compare, we return for 16 from there. We get 16 here in the previous max, and then we get arr dot length minus 2 for this one. Then we get arr length minus 3 for this one. Arr dot length minus 4 for this one, right? So this is where I think we are getting minus 1 as the index, right? ARR dot length is 4, and for the last iteration we are comparing it with the we are going one step beyond is what I'm thinking. So we'll have to draw the stack trace for it and compare. So for this we are comparing with this for this element, right? So if index is equals to 1, then we are comparing this element and this element, and index is equals to 2, then we are comparing this element with all the other, and if index is equals to 3, then we are comparing with this element and all the other elements. But we have 4 stacks loaded. That is the problem that we have, right? Let us try to draw the stack trace for it, and let's try to find out the solution. So this was about the last question that we had did. Let me have this here. Let's try to have the stack trace created. So what we'll have first? So we'll have, let's say, we have an array 1, 2, 3. What array do we have? We have an array of this. We have r max f retrieve max. Let's say, no, let's not code. Let's not have the whole method name here. So if we give it int and if we give it 5, not 5, not, we don't give 5, we give 4, then what happens is it will make another call with this, with 3, then it will make another call with 2, call with 1, then with 0. And once it makes a call with 0, it should return. What does it return? It returns arr.length minus 1, it returns 16. Once it returns 16, it's just stored in previous max. And then we do arr.length, which is 4 minus 1, 3, 0, 1, 2, 3, right? Minus 1. Okay, so we compare 13 and 16. So 13 is previous max is greater, right? So we return previous max. So from here we return 16 only. Then we compare arr.length minus 1 minus index. So this is where uh, we have the previous max again as 16, and 4 minus 1, 4 minus 1 is 3, 3 minus 2. Index is 2 here, right? 3 minus 2 is 1. So this will be compared, 20 will be compared with 16, and we get 20 here because it is the maximum. And then we have this. Okay, we get 20 here. Then what do? We compare this 20, the previous, we have this 20 in the previous max. Then we compare it with this element, 29. So between 20 and 29, we have 29 as the maximum. So we return 29. So this is where the issue lies, right? So And then what happens is we are comparing 29 with arr.length minus 1 minus index. So this is where we are wrong. So how can we tackle this condition? So the first and the brute force approach, and the only approach I can think is that if we have both the, we can have one more if condition, right? And if that condition is satisfied, we return the previous max. What do you think? Think. To tackle this condition, how do you tackle this condition? It is comparing 29 with 1 less than. So if index is equals to 0, then we return arr.length. So one thing we can do is we can, if we return 0 and if we don't have this index, let's say this index is what is causing the, if we don't have this minus 1, because this minus 1 is what causing the problem, then we'll solve the problem, right? So the only thing is that we will have duplicate comparisons, right? So first we'll return 16 and then we'll compare 16 with 16. Then we'll return 16 only. Yeah. So I think that will solve the problem. So this will solve the problem definitely. Let's try to run it. So let's think first before running. So this will return 16. Okay. This will compare 16 with 16 and return 16 itself. This will compare 16 with 13 and this will return 16, and then this will compare 16 and 20 and return. Mm, let's do it again. Let's trace it again. So this will, yeah, if ARR of length is 0, then it will return 16, right? It will return 16, which is the last element. And once it comes here, it will have a fight between 16 and 16. So and it will return 16 here. Then it will do arr.length minus index, which is 4 minus 2 is 2, 0, 1, 2. It will compare 13 and 16, right? 13 and 16, who wins? 16 wins. So we'll have 16 here. Now we'll have 4 minus 3, 1. So 20 and 16 will be compared and we'll get 20 here, right? And now in this method, we'll compare 20 at arr.length, which is 4 minus 4, 0. 0th element and 20 will be considered. Yeah, so this will work. Let's try to solve it. Let's try to run it, not solve it. 29, 30, 20, sorry, not 30, 20, 13 and 16. Yeah, so it gave us 29 as the max index. Let's try to have some other variations of 5, let's say. Yeah, so it is working. So this is how we have to improvise, right? We have already solved this question using two different variations. And this is how, if we get index out of bounds exceptions as -1, we can we can evaluate that we are going somewhere beyond the 0th element, like to the left side of the 0th element, and that is where we need to think and we need to improvise our code. So this code, like we had discussed, it can be solved using different ways. In this solution, we had discussed it that if we start the comparison from the 0th element first, right? So we start from the 5th and then we start the comparison from the 0th element, meaning From this element we start the comparison. It doesn't matter, right? From if we started from here or we started from here, it doesn't matter because anyway we have to iterate over the whole array. If the problem was finding the first index or the last index, then it would be a different scenario. Then it would have matter if we start from here or if we start from here. But it doesn't matter now because we have to iterate over the whole array. So let's try to discuss this solution. So we started from the last index and we hit index is equals to 0. Then we return 29. Then we compare 29 and 20, right? What are we doing? Let me check. ARR of index minus 1. What is index minus 1? So we'll have index minus 1 is, so we'll fall. So here also I think we'll have some uh, duplicate comparisons. So this will compare 0 and 0, right? 0th element with 0th element, right? Because we are, uh, so are we ARR of index, which is 0th, yeah. So here we are doing comparison of 0th element with 0th element, right? Yeah. So which will return the previous max only, right? And then we compare this element with this element, then we compare this element with the max of these two elements, which is 29. So this is also one approach that we had solved with. There is this other approach that we had also discussed. I'm not sure if we had discussed this or not, but here we start the comparison from the last element. So we give the index as 0 here. So if we give index as 0 and then if index is, oops, sorry, we are discussing this one, right? So if and then we increment the index, and when we hit the last index, when we hit the array dot length, we return the last index. So this will return this. Like this is a approach similar to the one that we had solved, right? And then we return ARR of index minus 1, right? Which is the last element. And then we compare the previous max with ARR of index. So ARR of index will be 4. So this is also where we are doing duplicate comparisons, I think. Yeah. So we'll be comparing the last element with the last element only for the first iteration. Then we'll be comparing the second last element with the last element, and then we'll be comparing the third last element with the maximum of these two elements, right? This is how we have solved this print array max solution. So the point I'm trying to make is having solving this problem in different solution. That's the point I'm trying. You can have n number of, not n number of solution, but you can have different solutions. You can think in different ways and you can improvise accordingly. Like I have improvised here. We were getting array index out of bounds exception with, so we with the index as minus 1, so we saw that it was occurring at 58. Then we drew the stack trace and we found that there was one extra comparison that we were making to the left side of the 0th element. So to avoid that, we removed the minus 1 that we had here. So yeah, you can also think about such different variations of this question and try to solve this. But that was all for this video. See you guys in the next one. Thank you.